All right, so we're told that the risk of being in an accident when driving a car um, is related to a person's alcohol content mathematically by the equation R equals 3e to the kx. So R is the risk of being in an accident, and x is the concentration, right here, x is the concentration of alcohol in the blood. K is a constant that we have to find. In order to find K, we have to be given some information. On part A, it says, suppose that a concentration of alcohol is 0.05. If that's the alcohol level, then the risk of being in an accident is 10%. R equals 10. So we can use that to find the value of K. So in part A, we're told that if R is 10, then X would be 0.05. To solve this equation for K, we're going to have to natural log both sides to remove the E. So we need to get the coefficient of E equal to 1 first. So we'll divide by 3. And so we have E to the 0.05 K. And so now we natural log both sides. The reason why we natural log both sides is it'll cause the E to cancel out. And so with the natural log and the E cancel out, we're left with 0.05 K on the right side. And on the left side, we have natural log of 10/3. Finally, to solve for K, we can divide both sides by 0.05. Or instead of dividing by 0.05, we can look at it as multiplying both sides by 0.05, which will avoid the complex fraction. So we could divide by 0.05 or multiply by 1 over 0.05. To make K a little nicer, instead of 1 over 0.05, if we move the decimal to the right 2 times on the 0.05, if I move the decimal to the right 2 places, that would turn it into 5. And if I move the decimal to the right 2 places on the top, that would turn it into 100. So 1 over 0.05 is the same thing as 1 over 5, which is 20. So I can write 20 instead of 1 over 0.05. That just makes it a little bit cleaner. And so that's the answer to part A. K is 20 times natural log of 10 over times, 20 natural log 10/3. Looking at part A, though, it actually wants me to round it to 2 decimal places. So to do that, since they wanted me to round to K, it's not essential at all to convert 1 over 0.05 into 20. I just did that to make it look nicer. But especially since they want me to turn K into a decimal anyway, it doesn't matter. So using my calculator, if I take the natural log of 10/3, it looks like I get 1.2039 and so on. But then I have to multiply that by 20. And after you plug this in my calculator, I see that I get, and they wanted me to round it to 2 decimal places, that'd be 24.08. All right, so there's the answer to part A, that's K. Going on to part B, using the value of K, what is the risk of if the alcohol level is 0.14? All right, so part B, now that we have K, we can plug that into our R equation here. So R equals 3e to the K, which is 24.08x. Now we can figure out the risk of being in an accident for any value of X, for any alcohol level. They want me to figure out the risk of being in an accident if X equals 0.17. So we're going to plug that in. R equals 3e to the 24.08 times 0.14. And then now we're going to use our calculator. Using my calculator, I'm using the E. And then I'm going to raise that to the 24.08 times 0.14 power. and I get 29.11 and so on. And I have to multiply that result by 3. And what did they want me to round to? It says round to the nearest percent, so that'd be 87. Yep. And the calculator, I actually get 87.34 and so on, but it says round to the nearest percent, so 87. So R equals 87, or 87%. So what this means is if a person's alcohol level is 0.14, the risk of that person being in an accident when driving is 87%. So there's a strong chance they'll be in an accident. Part C. If the risk is 100, it says what concentration of alcohol corresponds to a risk of 100%. So sort of like what alcohol level basically guarantees this person to be in an accident. So our equation is R equals 3e to the kx. But I should have went ahead and plugged in our, we know what k is. So k is 24.08. I should have just went ahead and started with this. And so R is 100, they're saying, and they want me to solve this for x. So we're trying to figure out what value of x, what alcohol level would correspond to a risk of 100. So to solve for x, we're going to have to get rid of the e. So first we'll divide by 3. And after I divide by 3, I'll be able to natural log both sides. And we're natural logging both sides in order to get rid of the e. And so on the right side, the natural log and the e cancel, so we get 24.08x. And on the left side, we have natural log of 10 over 3. And finally, divide by 24.08. So natural log of 10 over 3 divided by 24.08 is the answer. That's the exact answer. But they want me to round to 3 decimal places. So I'm going to pick up my calculator and I'm going to type in natural log of 10 divided by 3 and then close the parenthesis and divide by 24.08. And I see that x is I see that x. So at this point, I've noticed that I have an error, a typo. If you're watching the video, you may have caught it. Back right up here at this step, it looks like I failed to copy the extra 0. I should have had 100. So the previous step, you can see I have 100 over 3, but then I wrote 10 over 3. So looks like I made an error. I copied it incorrectly from one step to the next. So I'm going back through and putting that extra 0 in there. So using my calculator, if I type in natural log of 100 divided by 3, close the parenthesis, and hit enter, and then divide by 24.08, I get x equals 0.1456, and then more numbers after that. But they want me to round to 3 decimal places, so that'd be 0.146. So an alcohol level of 0.146 would correspond to a risk of 100. So this isn't part of the problem, but if we were to graph this equation right here, R equals 3e to the 24.08x, it would look like this. Now here's the alcohol level that's x, and then the risk is on the y. Notice if we put 0 in for x, we'd get 3e to the 0. E to the 0 is 1. And so 3 times 1 is 3. So if the alcohol level is 0, the risk is 3. So, basically what this is saying, if a person doesn't have any alcohol in the system, if they drive, there's a 3% of being in an accident, you know. But as the alcohol level increases, the risk of being in an accident will increase as well. And the graph will go like this, an exponential, it'll go up. So as the alcohol level increases, the risk will increase at a pretty substantial rate. It'll increase exponentially. Part D says if a person has a risk of 15% or more, then that person should not have driving privileges. Then what concentration of alcohol should a person be arrested and charged of the DUI? So the government is saying that they've decided that if a person has a risk of 15%, that's where they should draw the line and charge the person with the DUI. But they want to know what alcohol level would correspond to that. So if the risk is 15, they want to know what X should be. What should the alcohol level content be? And we do Part D exactly like Part C. It's just that instead of 100 in for R, we plug 15 in for R. And everything else is going to be the same. So we go through the same motions, divide by 3, natural log. So Part D is going to be the exact same thing as Part C. It's just that instead of 100, it'll be a 15. In fact, we could really just come down to here, to this part right here, and replace the 100 with the 15. That's the only thing that's going to be different. You know, so again, we would divide by 3, natural log, and then divide by 24.08. So the only difference between Part D and Part C is the 100 is a 15 now. I'm trying to figure out what alcohol level would correspond to a risk of 15 instead of 100. And then I'm going to use my calculator. Natural log of 15 divided by 3, close the parentheses, and then divide by 24.08. And I get, using my calculator, I get 0.0066837 and so on. But in Part D, it says round to 2 decimal places. So the alcohol level for DUI would be 0.07.